Artificial intelligence is supposed to change everything, but there is one problem nobody can solve with a better algorithm. AI is getting incredibly powerful and incredibly hungry. Not for data, not for money, for electricity. And we may not be able to build enough of it fast enough. The world's biggest technology companies are spending hundreds of billions of dollars racing to build the infrastructure behind AI. More chips, more servers, more data centers, bigger models. But suddenly, the race isn't just about who has the best AI. It's about who can actually find enough electricity to turn it on. And what is happening behind the scenes is much bigger than most people realize. In 2050, data centers consumed roughly 485 terawatt hours of electricity worldwide. By 2030, that figure could reach around 950. That's slightly more electricity than Japan consumes today, just for data centers. And AI-focused data centers are growing even faster. Their electricity consumption could roughly triple by the end of this decade. Here's where the numbers get absurd. An advanced AI server rack is roughly the size of a large refrigerator. By 2027, a single rack could have peak power demand equivalent to around 65 households. One rack. Now, multiply that by thousands. Then multiply it by dozens of new AI campuses. The largest data centers are no longer buildings. They're becoming industrial-scale energy consumers. A conventional data center might use tens of megawatts. A hyperscale AI facility can exceed 100 megawatts. And some of the largest projects can demand power on the scale of entire cities. This reveals something important. The AI boom isn't only a software revolution. It's becoming an infrastructure revolution. And infrastructure has one huge disadvantage. Software can scale almost instantly. Power grids cannot. A new data center can be planned and built in just a few years. But major new grid infrastructure can take far longer. Planning, permits, land, equipment, construction, connections. New transmission projects can take years to complete. Some major grid projects stretch well beyond the construction timeline of the data centers waiting for them. And then there are transformers, not the robots, the enormous machines that make modern electricity grids work. These are complicated, expensive pieces of equipment, and demand has exploded. Waiting times for critical grid equipment have increased dramatically. Large transformers can take years to procure, which creates a bizarre situation. You can have the land, the money, the GPUs, the building, and still have nowhere near enough power to operate it. And for an AI company, a billion-dollar data center that can't switch on is basically a very expensive warehouse. This problem becomes even worse because data centers tend to cluster together. They want fiber, workers, existing infrastructure, reliable networks, and proximity to other data centers. But when everyone builds in the same place, everyone is competing for the same electricity. And eventually, the grid hits a limit. This is no longer theoretical. In August 2006, PJM, the largest regional power grid operator in the United States, proposed an extraordinary emergency measure. When the grid approaches its limits, some data centers could be required to move on to backup power. Think about what that means. Electricity demand from computing is becoming large enough to matter at the level of grid reliability. And this is where the story takes an unexpected turn, because big tech knows exactly what is happening, and their response tells us how serious they believe the problem is. They're going nuclear. Microsoft backed the deal supporting the restart of a reactor at the former 3 Mile Island nuclear site. Why? Because nuclear power offers something AI desperately needs: large amounts of electricity around the clock. Solar and wind can provide enormous amounts of energy, but their output changes with weather and time of day. AI data centers don't want electricity only when the sun shines. They want it every second, every minute, every day. Google signed an agreement with Kairos Power, aimed at enabling up to 500 megawatts of advanced nuclear capacity. The first project is targeted around 2030, with additional deployments planned after that. Meta has gone even further. In 2026, Meta announced nuclear agreements that could support up to 6.6 gigawatts of new and existing clean energy by 2035. 3 of the biggest technology companies on Earth independently arrived at the same conclusion. AI needs power. A lot of it. And this changes the economics of the entire AI race. During a gold rush, fortunes aren't only made by the people finding gold. They're made by the people selling the picks and shovels. For AI, NVIDIA sold one of the most important picks and shovels. But the next ones may look very different. Transformers, power generation, grid equipment, cooling systems, energy storage, transmission. The companies controlling these bottlenecks could become just as strategically important as the companies building the models. If you enjoy seeing the hidden business systems behind technologies everyone else is talking about, subscribe, because this story is only getting bigger. Electricity isn't even the only physical constraint. All that power becomes heat. AI chips can run at extraordinary power densities. That energy has to go somewhere. So next-generation data centers increasingly require sophisticated cooling systems, including liquid cooling. And depending on the design, cooling can introduce another resource into the equation, water, which creates another difficult question. Where should these giant AI factories actually be built? The best location may no longer simply be wherever land is cheap or fiber is available. Increasingly, access to energy may determine geography. That could push more projects toward places where electricity can be generated locally. Some facilities may increasingly behave less like ordinary buildings and more like miniature power systems with their own generation, their own storage, their own backup systems, and their own strategies for interacting with the grid. Natural gas is also expected to play a major role because reliable electricity is needed before many next-generation nuclear projects can arrive. So, despite the simple headlines, there probably isn't one energy source that solves this. AI will pull power from almost everything. Renewables are expected to supply a large share of the additional electricity. But natural gas, nuclear, storage, and expanded grids will also be needed to provide dependable capacity. And this is why the real bottleneck isn't simply producing more electricity. It's delivering the right electricity to the right place at the right time. AI also behaves differently from many traditional industrial nodes. Demand can change rapidly as enormous computing workloads start and stop. That forces utilities and grid operators to adapt to a type of customer that can consume staggering amounts of power. And remember, AI isn't the only thing asking for more electricity. Electric vehicles, factories, air conditioning, semiconductor manufacturing, electrification, they're all competing for additional grid capacity, which means the question isn't simply, can we power AI? It's, can we power AI while also powering everything else we're trying to build? And suddenly, the future of artificial intelligence looks much more physical than we were told. Behind every magical AI answer, there are chips. Behind the chips, there are buildings. Behind the buildings, there is an electrical grid. And without that grid, the intelligence disappears. So, the next phase of the AI race may not be won only by the company with the smartest model, or even the company with the most GPUs. GPUs without electricity are useless. The winner may be the company that can secure the land, the infrastructure, and enough reliable power to keep millions of chips running. AI started as a software story. Then it became a chip story. Now it's becoming an energy story. And that may create an entirely new gold rush, hiding in plain sight. Because if AI really does consume electricity at the scale currently projected, someone has to build all of this. And the biggest winners of the next AI boom might not all be AI companies. They might be the companies that keep the lights on. The biggest stories in technology aren't always the ones everyone is talking about. They're the systems quietly making everything else possible. Subscribe if you want to understand what's really happening behind the technologies shaping our future.